Dear students, in this video you will be learning what is superposition theorem and how to apply it to electrical circuits. To understand what is superposition theorem, let us consider one example circuit. In this circuit, 1.1 ohm is internal resistance of 5 volt source, 0.1 ohm is internal resistance of 10 volt source, and let us say we are asked to calculate current through 5 ohm resistor. Now how to find current through this 5 ohm resistor using superposition theorem, that we will see. Here in this circuit, now you can see only 5 volt source is considered and 10 volt source is replaced by its internal resistance of 0.1 ohm. I am going to make use of KVL, that is Kirchhoff's voltage law, to find current through 5 ohm resistor. Therefore, I have marked here two mesh currents, I1 and I2. So now write here applying Kirchhoff's voltage law to the meshes in first mesh. I get equation 5 equal to 1.1 I1 plus 3.9 I1 plus 5 I1 minus 5 I2. Simplifying it, we get 10 I1 minus 5 I2. Let us call this as equation 1. In second mesh we are having no voltage rise, therefore voltage rise is 0. Voltage drops are 5 I2 plus 4.9 I2 plus 0.1 I2 minus 5 I1. Simplifying, we get minus 5 I1 plus 10 I2. Let us call this as equation 2. Solving equations 1 and 2, we get I1 equal to 2 by 3 ampere and I2 equal to 1 by 3 amperes. Now we will find current through 5 ohm resistor due to 5 volt source. Current flowing through 5 ohm resistor due to 5 volt source I1 minus I2 is equal to 2 by 3 amperes minus 1 by 3 amperes, that is equal to 1 by 3 ampere. Next, what we will do is we will replace 5 volt source by its internal resistance of 1.1 ohm and find current through 5 ohm resistor due to 10 volt source. So now in this circuit you can see only 10 volt source and 5 volt source being replaced by its internal resistance of 1.1 ohm. I1 dash and I2 dash are the two mesh currents due to 10 volt source, and using these two currents we will find current through 5 ohm resistor. And to find I1 dash and I2 dash, once again we will make use of Kirchhoff's voltage law. Applying KVL to mesh 1 and 2. In first mesh we have no voltage rise, therefore 0 equal to I1 dash into 1.1 plus I1 dash into 3.9 plus I1 dash into 5 minus I2 dash into 5. Simplifying we get 10 times I1 dash minus 5 times I2 dash, and let us call this as equation 1. If we apply KVL to mesh 2, their voltage rise is minus 10 volt because current I2 dash is flowing into the source. So minus 10 equal to minus 5 I1 dash plus 5 I2 dash plus 4.9 I2 dash plus 0.1 I2 dash. Simplifying we get minus 5 I1 dash plus 10 I2 dash equal to minus 10, and let us call this as equation 2. Previous equations also I have called as 1 and 2, therefore I will make these as equations 1 dash and 2 dash. Now solving equations 1 dash and 2 dash, we get I1 dash equal to minus 2 by 3 ampere and I2 dash equal to minus 4 by 3 ampere. Current through 5 ohm resistor due to 10 volt source I1 dash minus I2 dash is equal to minus 2 by 3 minus of minus 4 by 3, that is equal to plus 2 by 3 amperes. Here you observe that I1 dash minus I2 dash is having positive sign, which means that this 2 by 3 ampere of current is flowing through 5 ohm resistor in the direction of I1 dash, that is downward. When we considered 5 volt source, then we had got I1 minus I2 equal to plus 1 by 3 ampere, which meant that 1 by 3 ampere of current is flowing in the direction of I1 and I1 is flowing in downward direction through 5 ohm resistor. Instead of getting positive sign here, if we get negative sign, then the current would have been flowing in the direction of I2. Now since current due to 5 volt source and 10 volt source both are flowing in downward direction, we have to add these two currents to get the total current through 5 ohm resistor. Total current through 5 ohm resistor is sum of currents due to 5 volt source and 10 volt source, that is I1 minus I2 plus I1 dash minus I2 dash, that is 1 by 3 plus 2 by 3 equal to 1 ampere. After solving for current through 5 ohm resistor using superposition theorem, now we can state superposition theorem as superposition theorem states that in any linear electric circuit having two or more than two energy sources means what? Voltage source or current source. Current in any branch may be calculated as sum of currents in that branch due to each source acting independently. So when we consider each source independently, then we have to replace all other sources by their internal resistances. So that is very important note here. We will write that note also. When we consider any source to calculate current through the required branch, other sources must be replaced by their internal resistances. Thank you for watching video.